Hey YouTube, what's going on? I'm Greg. Welcome back to my computer lab. Today we're going to work on the sump for our 30cc Wallaby engine. We're going to be looking at the Fusion360 files to machine the inside, the sides, and the bottom. We'll be reviewing topics we've touched on before, including loading an STL file that's representative of the rough stock that we've pre-machined on our mill. We'll be modifying the CAD model to create keep-outs, so we don't machine areas that have been previously machined elsewhere, like the crankshaft bores we machined on our lathe. And finally, we'll delve into some of the operations, looking at tool feeds and speeds, depths of cut, tool loads, and things like that. So we created an IGES file out of our CAD program and imported it into Fusion360. That's this model here. Now we also, if you watched the last video on manual machining, we roughed out most of this material from the inside of the sump. This is an optional step, but something I like to do because I can remove the material much quicker on the manual mill with a drill bit than I can on the CNC machine. So let's take a look at that real quick. Then we created a simple STL model that reflects the geometry created by roughing out that material on the manual mill. Right here. This was a STL file that was imported, and then down in our setup, you can see here this area has been removed. In our setup, right click, hit enter, stock, we say from solid, we click the mesh, and we select this STL file. We've covered importing stock before in a video entitled Fusion360 using stock. I'll put a link to that in the description below. Another thing I'd like to cover is how to mask part of the model that we don't want to machine. In our case, we've got these bores that were created on the lathe and the precision surfaces. We don't want the CNC machine to be machining in this area at all. We simply want to machine down and machine this cavity. One way to do this is to select areas within the model that we'd like to have machined. And we could do that. We could click all of these little areas, but there's no simple little box that we could click that would allow us to select just the area that we want machined. A much simpler method is simply masking those out in the model itself. We've explored different ways of doing that. The simplest, I think, is to just pop back into the design environment and create a sketch. Here's a sketch that I've created. Let's just pop in and edit this. It's simply two rectangles, one within the other, and they exclude the ends of the sump, which will allow me to machine just this area in the middle here. Going back into the manufacturing environment, looking at our first machining operation, you can see these blue lines here represent the tool path. We've successfully masked out the ends of the sump, so that area is not machined. And then by using our STL stock, we're not machining out the middle, which has already been machined earlier on the manual mill. Before we look at the operations, let's review the origin point. I've got mine set right in the middle of the part. This is easy for me to touch off on my machine by touching off the four sides and then zeroing to the center. The way we set our origin point is we right-click on Setup, click Edit. The first tab is Setup. I've selected the Z and X axis. I'll come over the model for Z and I'll click a vertical edge. And then for the X axis, I'll click an edge that I want in the direction of my X axis. And then for box stock, I'll click the point that it presents to me right smack in the middle of the part. So I've decided to use 4 different operations to machine the inside of my sump. My choices depend on the capability of my machine and the tools that I have on hand. The first 2 operations are done with a 1/4 inch flat end mill that only has a 3/4 of an inch flute. The first operation, right-clicking on it, opening up Edit, looking at the first tab, which is the tool, I'm running my spindle speed 8,000 RPM, and I'm running the cut feed rate at 12 inches a minute. However, in the second operation, I'm also running at 8,000 RPM, but I've slowed the cutting feed rate down to 9 inches per minute. This is because on the first operation, I have a 1-inch stick out on this end mill. On the second operation, I have to reach down into the pocket, so I go to a 1.5-inch stick out, and I slow the machining speed down. I want to make it clear that these speeds and feeds that I've been using on my machine, the spindle speed and the feed rate of my machine, have been derived over a period of time of experimentation and understanding my machine. There's many factors that go into what will work best for you. So if you use any of my Fusion360 files, I would recommend slowing your machine down or substituting numbers that you know work for you. Just a caution for you. Moving on to the other tabs. The second tab is used to select the area I want to machine. Here I've selected bounding box, which is the whole part. The third tab is used to select the depth. If we look at the side of the part, I start at the top and I drop down 0.75 inches. If we look at the second roughing operation, we can see that I start at -75 inches and then go all the way down to the bottom of the part. Next, we'll take a look at the passes tab. When roughing, I like to use as much of the side of the tool as I can. In this case, I'm taking 2/10 of an inch step down, and I'm cutting into the material 50 thousandths. We could do that the other way around and step down 50 thousandths and cut 2/10 of an inch of material away, but we would be only using the bottom 50 thousandths of our tool on each pass. This way, we're using 2/10 of an inch of the tool, and we reduce the wear and increase the life of the tool. Finally, since it's a roughing pass, I'm leaving 20 thousandths of an inch of material both in the radial direction, which is the side of the tool, and in the axial direction, which is downward. For the finishing operation, I use a long flute end mill and a ramp operation, where I circle around working myself down into the part. I'm running the spindle at 8,000 RPM and a cutting feed rate of 12 inches per minute. And I'm only removing the 20 thousandths of an inch of material we left in our roughing pass. And I'm descending 1/10 of an inch on each pass. You notice here that on my stock to leave, I say -2 thousandths of an inch. This is because on my machine with a climbing operation, the force of the tool is away from the workpiece. And I need to actually tell the machine to cut 2 thousandths of an inch more into the material to arrive at my proper dimension. And the final operation is a horizontal milling operation where we simply machine the flat area at the bottom of the sump. Machining of the sides and bottom of the sump are continuations of the same themes we've been using before. In machining the side, we have an adaptive roughing operation, removing most of the material, leaving 20 thousandths of an inch axially and radially. And then a parallel operation using a ball-end mill, just moving up the side of the part, which will give us the curved appearance of the sump. We start with an STL file as our raw stock, which represents our starting point of our machining operation. The raw stock was machined earlier by taking 2 cuts on our manual mill, creating this step, and then a CNC operation creating the countersinks for our socket head cap screws to rest when we screwed our sump to the crankcase before we machine the crankshaft bore down the middle of the sump crankcase assembly. Notice in this one file, we machine both sides and the bottom of the sump by having multiple setups. Here I've got a setup with the origin set in the middle edge of the sump, machining the right side of the part. I have another setup on the other side, again in the center top edge of the part. And finally, I have a setup machining the bottom centered right in the middle of the part. And we're able to simulate the machining of the whole part. one side, there's the other side, and there's the bottom. And there's our finished sump simulation. That's pretty cool. Looks like there's two operations we didn't discuss, and that's the machining of the two holes for the oil drain and the oil pickup. We use a 3/32 flat end mill and simply ramp down into the hole. We need to tap our oil drain and our oil pickup hole, and our sump is done. Well, I'm Greg. Thanks for visiting me in my machine shop. Until next time, take care.